So now let's try an example. Let's say that we have a mean of 10 and a standard deviation of 5. Now, you know how the z-score is calculated. So really our question here is, what is the probability that an observation would be between the mean and 17.5? So to do this, we compute the z-score first. So 17.5 minus its mean 10, and then divided by the standard deviation, which we have listed here at 5. So that's 17.5 minus 10, which is 7.5. We take that number divided by 5, the standard deviation, which gives us a z-score of 1.5. Now, what we're looking for is the part of the curve, what percent of the curve is between 10 and 17.5. So it's highlighted by this yellow area here. So between the z-score of 0 and the z of 1.5. So you don't have to memorize this unless you're someone like John von Neumann. You can just look it up in the z-table, knowing the z-scores that you're looking for. All of the old physical statistics textbooks, those, the big, heavy ones that you would have those in the back. When I took stats courses, we would have the Z and the T tables and all that sort of stuff we would need for the exams. It's an eCampus for you under the tables folder thing. You can always use it in any quiz or any exam. This is very standard practice. So let's look at the Z table. I have a little piece of one cut out here. So we're looking between 0, the mean, and the z-score here of 1.5. So we can use this table, look at right here, starting at the z-score of 0, and then going to the z-score of 1.5 down here. So we just look at where those two cross on the table, right here at 0.04332. So what this tells us is that there's a probability of 43.32% that an observation would fall between 10 and 17.5, or between the z-score of 0 and 1.5. So there's a 43% chance that an observation would be between 10 and 17.5. So let's look at another question. What's the probability of an observation being above 17.5? So that's going from 17.5 here all the way up to infinity. So we know that between 10 and 17.5, it was this area right in here was 0.4332. We also know the entire part of the curve from this mean all the way up to infinity is 0.5. So to do that, very simple way to work around it, we can just subtract the 0.4332 from 0.5. So we know the probability of being between here, again, 0.4432, probability of being all the way up here to infinity starting at the mean is 0.5. So we can just, in this case, subtract the two. When we do that, we find the answer is 0.0668, or almost a 7% chance that an observation will be above 17.5. So now, another question, what is the probability of an observation being above 4? So 4 here is below the mean of 10 instead of above it. So again, we want to find out what the z-score is, and from the z-score, then we can determine the probability. Those are the kind of the steps that we take. So our formula is z equals the variable minus its mean. So here, 4 minus 10, and divided by the standard deviation. So that's -6 divided by 5. So the z-score is -1.2. Note that the 4 is below the mean of 10, so the z-score is going to be negative. When the z-score is below the mean, it will always be negative. So we're trying to find the area here in yellow, starting at 4 and then going all the way up to infinity. So if we go back and look at the z-table, look between a z-score of -1.2, we find 1.2 here, and 0 gives us 0.3849. So that tells us basically between 0 and the 1.2, or in this case, it would be on this side, on the negative side. We know that the other side is 0.5, So here we have 0.3849, what we just pulled from the z table, and then zero point 0.5 on this side. So adding them together, we get 0.8849, or basically an 88.5% chance that a value selected at random is going to fall between 4 and then infinity on the right.